Consider the following 2018 PUMAC problem. We're given a grid and starting from the point 0, 0, we want to reach the point 6, 6. And we're only allowed to have up or right moves. And in total, we will have to make 12 moves, I guess. So this is the shortest number of moves needed to go from 0, 0 to reach the point 6, 6. So along the way, what I want is to place 6 roadblocks such that the only allowed movement would be to follow this red track. I want to go from 0, 0 all the way up to 0, 6, and then from 0, 6 to 6, 6. So this is the only path. So our only allowed move is up, 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 and followed by 6 right moves. And where should I strategically place my roadblocks so that that would work? After some experimenting, for instance, one way that roadblocks would work would be, for instance, you can place all the roadblocks like this. That will indeed force the driver to keep going up because right is blocked already. Keep going up because right is blocked. Once you are here, again, right is blocked. Keep going up, 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 up. And then once you reach here, you have no other option. You have to make right, right, right in the remaining moves. So putting the roadblocks like this works. Alternatively, you can obviously put it how about this, for instance? Would that work if I did put it like, I don't know, so let's try this, the diagonal. Obviously, the diagonal will also work. Why? Because, well, even if you did go like this, eventually you realize you cannot pass that barrier. You need to go back, but yeah, you can't do that. So you're not allowed to go back. The only moves allowed is up and right. So therefore, putting it in a diagonal like this works, but putting it in kind of combinations would also work. One thing which is interesting is this won't work. What won't work, for instance, if I put the roadblocks like, say, I put one here, here, I don't know. Let's put the roadblocks like this. Would that work? Initially, it seems it might work because at least I know that, okay, let's keep that blue color. I would have to keep going up, 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 up to this point. I will keep going up, but then I can do right and then back up, and then I can go like this. And it is clear that this won't work. So for this type of coloring to work, I have to put one of the 6 roadblocks at a particular location. It's a must. And it is, and after experimenting, I'm sure you guys will all figure it out. It's this one. This one has got to have a roadblock. That's it. So that's pretty good. Then afterwards, after making this critical observation, now how do we count the number? How to place the roadblocks, right? Again, after making some experimentation, you would just realize that you have to have either a roadblock in each of these columns. So in total, we have 6 roadblocks, so 1 in each of these columns, or you have to have 1 in each of these rows. That will make sure that you can never cross a certain, so you can never cross for instance, if we put 1 roadblock in each of these rows in a certain way, then we force it to keep going up, 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 all the way like this. And then we can, or for instance, if we put 1 in each of these columns, for instance, like this, again, even if you go inside, it's not a good thing. You need to come out, and then it's not possible because you have at most 12 moves again. So yeah, that's pretty decent. I don't want to confuse you guys even more, but so the best way to do in this case, I would say, is once you make this critical observation, to start with smaller cases and then build up to all the way to the 6, from 0, 0 to 6, 6. So what I want to do is gradually start from 0, 0 to 2, 2. And obviously, for me to go to 0, 0 to 2, 2, I will go to 0, 2. I want to force it to go to 0, 2, and then eventually to 2, 2. So my grid will look like this. It's a pretty small grid. So we start at this point here. By just that critical observation, I just realized that I have to have 1 roadblock here because I'm in the case where I end up at 2, 2. I need to put 2 roadblocks. So where would be the other roadblock? Well, for the other roadblock, I have three choices. I can either put the other roadblock here, or here, or here. So therefore, in total, like I said, there are three choices. So I can either put the roadblocks like this, so that would force the driver to go up, up, obviously, and then right, right. Alternatively, I can put the two roadblocks to block it like this. Or finally, I can put the two roadblocks like this. Like I said, what's common in all these three configurations is this one has got to be one of the roadblocks. But the other roadblock, I have choices. So therefore, for this one, we have the answer is 3. Okay, so this is the case where we start at 0, 0, and we end up at 2, 2. Okay, let's spice things up a little bit. Let's have a look at the other case. How about we start at 0, 0, and we end up at 3, 3. So this is our starting point, 0, 0, and we end up at 3, 3. By now we are aware that we have to place 1 here for sure. And then how many ways can we finish? So, well, I can obviously put it like this, 1. Do you guys agree that this is symmetric with this one? That's pretty nice. And how about this? I can put the blocks like this. Maybe I should do it with a different color. Okay, so there you go. So this one has a symmetry, and we also already talked about it. How about this one? This one also would block it. If I put it 1 here, and 1 here, that would also block the tracks, the roads. What else can I do? I can do it like, I can use yet another color. Or let's draw a different picture. So far, each of these, they have their symmetry, right? For instance, putting it like this red is the symmetry of this, so this would work, as is this one. So I can go like this, and then so these would be the 3. But then obviously this also works. I can put it like on the diagonal, or yet alternatively, let me draw just a new picture so that I convince everybody. I can start here, I can go here, and then go back here. So I can put them like that. Or alternatively, for the other case is I can also, the symmetry would be like this. All right, so in this case we have 4 here, the diagonal plus 1, and then 2 more here. So the total here would be 7. I do have, am I missing any? I have 1, 2, 3, 4, 9, I should say. Oh, sorry. What am I doing? Hold on. So I have 1 down, 1 all right. So that's 2, plus these green ones, that's 2 more, plus the diagonal, that's 1 more, and then these 2, and and then there's one more case that I totally forgot. It's this one. Okay, so we can also go covering this, and going down like that. That would also block the way, and the truck driver would have to go like this. Does that make sense? And obviously this one also has a symmetric one, which is this way. There you go. So there's 2 more for that one. So total would be 9. All right, so we have to find a better way to do this, because this is torture. And obviously, because we are in the business of counting number of tracks, I don't know if you guys remember, there are multiple different ways to do it, but probably the most convenient way would be the following. For instance, let's count this. Suppose that you have this this case. You want to start here and then end up here. I'm sure you guys already remember. So how many ways can we go from this to this without restriction? So 1 way, we start here. How many ways can I end up here? 1 way. How many ways can I end up here? 1 way. How many ways can I end up here? 2 ways. Here, 1 way. Here, 3 ways. I think everybody remembers this. 3 ways, and finally 6 ways. Obviously this is 4 choose 2. I'll use a similar strategy for this one too, and let's see if I can get the same 9 on this case. So that will significantly reduce our headache. So here we go. So we start here, 1 way. How many ways can I go down? Well, this is tricky. Let's do the diagonal first. there's only one way I can go from 1 to 1 there, that's it. And then I can just put it, so this one is also 1. Now for this one, yes, that one is 1, but this one is different. I can end up at this point either. So do you guys see what I'm trying to do? I'm trying to block the passage of the truck. So that would be 2 ways. How can I block the truck in 2 ways? I can either do down down like this, or put a block like that. So that would block. So 2 ways. Well, I can continue blocking. How many ways can I put 1 here? Well, I can do 1 1 here, and then I can come here, or I can do 1 1 and then go down. Again, 2 choices. Finally, this one is 1 2 and 2, and that's wrong. What did I do wrong? Oh no, this is correct. Yeah, this is 9. Yeah, 2 plus 2 plus 1 plus 2 plus 2, that's 9. All right, let's keep practicing. How about the 4? The 4 case is the interesting case. If we can figure the case with 4, then the question is over. We solved the question basically. So let's be very careful on this one. So how can I block the passage? Well, I can starting here one way. Okay, we agreed on that. Obviously here I used symmetry, right? So once I'm done here, I just replicate it. So that was pretty easy. How many ways here? I can either cover it like that, or I can do it like that. Do you guys agree? So therefore, there's really 2 ways. Oops, come on. There we go. Okay, so this one is 2 ways. How about, well, this one is 1 way. This one is either I can cover it like 1 1 here and then here, or I can do this one, and then here. So there's really 2 ways, but this is exactly this anyways. So and then does that make sense? So I didn't gain anything new. So now I'm adding the new layer. Okay, so this one would be, okay, this is interesting. Okay, how many ways can I end up here? Which 2? So I can end up here either by following this or this. I can block it this way, so 4 ways. Or I can, so how about this one? I can do it like this, or like this, so 5 ways. And for this one, I can either do it like this or like this, 3 ways. And then finally, this one is 1. All right, so it turns out the first time I counted this, I kept counting it this way. And that's a wrong count, by the way. So 10, 18, 24, 25. No, I'm missing 2 blocks. And this is the part which is kind of interesting. So the blocks don't have to be connected. So here is another block, and try to convince yourself that this works. I can put it like here, here, here. And then I don't have to put, so currently in my current count, I'm assuming that I have to put it in one of the 3 locations, one of these 3 locations, but that's not necessarily the case. So what I can do is, let me do it again. I can start with here, 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 and then I can put a block right here as well. Does that make sense? So, and again, it will prevent the truck driver from driving, and well, you might say, hey, how about the truck driver go like this, go down? No, you are not allowed to do that, first of all, and this is more than the moves that we need here. We need 8 moves, and this have 2 additional moves, so you are not allowed to do that. So you are only allowed to do up or right. All right, so therefore I have to make a tiny adjustment. So actually, let's just do it like this. So cancel those 4s. So the correct count would be, I need to also add this one as well. So that would be rather 5 and 5 here. I hope I confused everybody. That was my goal. So that's a 27 indeed. And that's it. So now we can add the next layer as well. And by the next layer, you guys will be an expert in this. So obviously, it's kind of surprising how someone can solve this in 5 or 10 minutes to get all the, I don't know, it's a challenging question, I would say. It took me, well, a good part of at least, I don't know, maybe 25 minutes, 25 minutes to solve this problem. So therefore, to get the crux move, basically, I kept undercounting it, but yeah. So Again, let's just do the count. So we start here one way. Well, we already established the initial few steps. 2 ways here, 2 ways here, 1 way here. Okay, so I'll just replicate these. 5, 5, 3, 1. And now the the challenging part. Let's see if you guys will be able to guess what the entries for the next row would be. So let's think about it. So pretty much the same way, along the same way. So for instance, if I have blocks like, let's say like this, so far I did use 4 blocks. I need to use 1 more. It's okay. I can put the next block either here or here or here or here or here. Does that make sense? So therefore I have, in order to get the count in this one, I need to add all these 4 above it. Does that make sense? So not only the directly above them, but all of them. So therefore 5 plus 5, 10, 13, 14 here. And I'll do the same thing here. Does that make sense? So this one will be also 14. So this one is a little bit different. For the following reason, I don't have to I don't have to add the number on the leftmost one, right? So therefore this one would be 9 only. Why? Because you can't quite block it if you have one guy here. For instance, suppose that you ended up like this, and then like this. So far you use your blocks 1, 2, 3, 4, and if you use the 5th one like this, that's not gonna work, because the truck driver can simply go like this, up, and then yeah, there you go. So that's not possible. So therefore when I count this one, the 9, I cannot add the 5 here. And pretty much the same thing for the next entry here. I can only connect with these 3 and 1, so therefore I won't let the truck driver. So if I have to exclude these 5s, so this one would be a 4 and this one would be a 1. 4, 9, 14, and 14. That's it. By now you are probably starting to see some patterns. Okay, I'll leave it to you guys to figure that one out. But I have 28, 31, 31, 60 is what? Oh, sorry, 31, 35 times. No. Am I supposed to get that? Okay. 28. Oh, sorry, what am I doing? 37, 41 times 2 is 82, plus 1 is 83. So I have 42 times 2 plus 1, which is 83 in this case. In the zeros, going from 0, 0 all the way up to 5, 5. I'm just now one step away, and by now I'm pretty proficient with the rules of this game. So what I will do is now we will just finish, and I'll give you the general way to solve this as well. There you go. So once it passes midnight, and if you are feeling sleepless, you work on these problems. Okay, there you go. 6, 6. All right, so again, there we go. So we start here 1, 1, 1. 2, 2. We already did this, so I won't bother. You guys can make the calculations. Be careful when you do so. 3 here, 1 here, and then okay, so we established this is a 14, 14, 9, and 4. Oh my, how did I do that? Oh, and then there's this 1. Okay, no, we are right. Okay, finally, okay, so I have this one is a 1. Actually, let's write the numbers outside. So this one is a 1. This one would be, I can only use these 2. So this one would be a 5, I would assume. And then we go to, for this one, we can use these 3 only. So that's 10, 14. For the next one, we use all these. So 14 plus 14 is 28 here. And for this one, we can use all of it. So that's a 42. And then all of it again, that's a 42. And obviously, that's it. That solves this problem. So we have 5 here, 14, 28, 42, 42. Yeah, so if you do the count, I think this one works. So we have 2 times 42 plus 42 plus 28, 14, 5, and 5, and then plus a 1. So that would be 2 times 42, 84. 84, let's say, plus, so I have 42 here, 47 is it? Plus 1, so that will give us 2 times 131 plus 1, which is 262 plus 1, 263. Yes, that's the answer. At this stage, you might want to consider a few things. If you can generalize this result to from going 0, 0. In this case, we did go 0, 0 to 0, 6 to 6, 6. But you can as well do the generalization from 0 n to and then to n. The key, well, by now, if you already played with these type of configurations, you realize there is some troll numbers here on the screen. Like this, for instance, we have 1, 1, 2, 5, 14, 42. These numbers are not just random numbers. They are very familiar numbers. They are Catalan numbers. So therefore, you should be able to establish a bijection that would significantly reduce the calculations, but during test conditions, that's probably not gonna work. You will have to probably solve it the way that I did. Start with a initial observation after a few trials, then solve the smaller cases. I did solve the 2-2 case, the 3-3, then we went over the 4-4, where is it here, the 4-4 case, and then we did the 5-5 case, and finally we did the 6-6 case. So gradually we built. But by the time the critical one was this one, the 4-4 case was the first one where we got this unexpected thing where we decided that when we are counting these numbers, so this one is a 1 because of that, this one is a 3 because of 1 plus 2, this one is a 5 because of the sum of all of it. So that's kind of how you should be doing the summation. Alright, so hope you enjoyed this video and looking forward to see you guys in our next lecture.